let's solve this quadratic then. First I'm going to divide by negative 0.1, and I'll end up with x squared minus 98x minus 99. Oh, that can be factored into x and x. Signs are different, and one positive, difference of 98. How about a negative 99 and a positive 1? So x equals 99, or x equals negative 1. So find the levels of the production that break even. Well, x equals 11 was a solution. X equals 99. And x equals negative 1. I don't think we're producing negative 1 units. So we can have 11,000, since x was in thousands of units, or 99,000, again, since x was in thousands of units. Now we have the rational solutions. All the possible, and this doesn't say, but this is the possible rational solutions. All the if we have a long polynomial, we don't know quite what the degree is. This stands for the coefficient of the nth term. This is the coefficient of the n minus 1 term, down to the coefficient of the x term, coefficient of the constant. The integer coefficients must be in this form, p over q, where p is a factor of the constant term. P is a factor here, and q is a factor of the leading coefficient. It's a factor. Now, here's our definition. Let's see how that really works. So, we are finding now the possible rational solutions. This is our P, and this is our Q, and we're wanting P over Q. The factors of Q, factors of 4, are 1, 2, and 4. The factors of 2 are 1 and 2. And we want P over Q, so we want the 1 or 2 over the 1, 2, or 4. So to find those possible solutions, let's start with the 1. 1 into 1 goes once. 1 into 2 goes twice. We're done with the 1. Now, 1 divided by 2 is 1/2. 2 divided by 2 is 1. We already have it. We're done with the 2. Now the 4. 1 divided by 4 is 1/4. 2 divided by 4, well, that's 1/2. And these could either be positive or negative rational solutions. These are possible. There's 4, or actually 8 of them, and there are only 3 solutions. So we know these aren't all, but these are the possible ones. Going to this equation, again is our Q, our P, and we want P over Q. The factors of 6, 1 and 6, 2 and 3. Factors of 4, 1 and 4, and then 2 and 2. So we'll have 1, 2, or 4 over 1, 2, 3, or 6. Now using that, plus or minus, because it could be either, 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4. Done with the 1. Now the 2. 1 divided by 2 is 1/2. 2 divided by 2 is 1. 4 divided by 2 is 2. And we're done with this 2. Now the 3. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 4 divided by 3 is 4/3. We're done with the 3. Now the 6. 1 divided by 6 is 1/6. 2 divided by 6 is 1/3. 4 divided by 6 is 2/3. So these are the possible rational solutions. Now we look at actually wanting to solve cubic and quadratic equations in the form f of x equals 0. First, we determine the possible rational solutions, as we just did. Then we're going to graph it to see if any of those values are x-intercepts. Which ones work? Those values are rational solutions. Find the factors associated with those and do division to find by these to confirm the graphical solutions and find some additional factors. Continue doing the synthetic division till we get a quadratic factor, and then we can use factoring or the quadratic formula to find the rest of the solutions. Let's see that in practice. We're going to solve this equation. First thing I'm going to want to do then, well, let's find the possibles. 1 and 2 are my Q's. 1, 3, 9, and 27 are the P's. And we'll again want P over Q. So 1, 3, 9, or 27 over 1 or 2. So that's plus or minus 1, 3, 9, and 27. That uses the divide by 1, divide by 2, gives us 1/2, 3/2, 9/2, and 27/2. Now I'm hoping 27/2 isn't possible. But here are some possible rational solutions. Let's look at what happens with the graph. Interesting. Where does it look like we have zeros? One is 0. Well, left-bounded 0 will work. Right-bounded. Looks like there may be one here, but I'm not sure. So let's say we're right-bounded at 2. We'll guess that as a 1. We were correct. So remember, 0 is a 1. What if there's another 0 right here? Let's find out. So second, we're 0. We're wondering about this 0 right here. So let's say it's left-bounded at 2, right-bounded at 5. Maybe we'll guess a 4. 2.9, that looks like it's a 3 to me. So we have it 1 and 3. Now let's go back.